This is my 2006 Toyota Tundra, and I'm going to show you something that's always bothered me about it. It's this cubby right here. You've got all this prime real estate, but then you've got this cubby that does absolutely nothing. Nice. You can put a few coins here maybe, but they'll bounce out. We've got two switch blanks that are obviously used for nothing because they're switch blanks. I've got this new 3D scanner that we're going to use to scan the interior surface of the vehicle, and then 3D scan this independently, and we're going to reverse engineer this organic kind of shape, as well as pick up all of your mounting tabs. What we're going to do is add a small LCD screen here that will display OBD PID data and give you the ability to read and clear diagnostic codes from a small screen right here. So let's get started. Got the Revopoint MetroY Pro 3D scanner. All right, nice little travel case. It's the important one right here. Wow, look at that. Handheld tripod. This thing's beefy too. It's all metal. Some lens wipes. Another tripod. Mounting pieces for the tripod. Power supplies. USB-C to USB-C. Oh, look at this. It's a little sample bust. The 3D scan. That's cool. And they pack all sorts of stuff in here. We've got our turntable. We've got a bunch of documentation in here. Here we go. Let's get started. We got the scanner here. Tripod. Plan is set this up, spin around, scan it. Plugged up and waiting for it to connect. Look, just connected. Make a new project. Tundra Cubby 001. Boom. Let this load. You can see some of the lasers turned on now. We are not going to do a marker scan. We're going to do a feature scan. As you can see, it's not really picking too much up here because it's black. This spray right here is worth its weight in gold. Cool thing is you can spray it just about on any material and it just vanishes after a few hours. It doesn't smell the greatest, but it works really well. We're going to give this a quick paint job. Hopefully, the scanner will be able to pick this up a little bit better. Check that out. It's picking up all of the details much better. Might need to move the scanner a little bit away. We'll move. I don't know. Yeah, look at that. It looks so much better. I'll let it do one full rotation and then we'll try a different angle and we'll do this workflow and probably take a few different scans and then stitch them together in post-processing. Got some complex geometry here. It's not getting all of it, but getting everything that we actually need. You can see that edge gets a little bit close to the frame. It didn't like that. All right, we'll go ahead and pause that, hit complete, and we're not going to do any post-processing yet. We're going to do a new scan. I'm going to push this a little bit further away. We'll stick it on its face. Try face scan. Get our depth. Get a little bit closer. And start. All right, let's see. This is looking decent. We're a little close. There we go. Stop that. It's not the worst. It's not the best either. Should be decent enough though. All right, I'm going to reset real quick. Okay, we're going to do one more 360 scan, let that go, and then we'll start doing some of the post-processing. I don't really remember where we started, but this looks decent. We'll stop that there. I think we've got a lot of good scans here. Yeah, we got 1, 2, 3, 4 solid scans. Don't need this anymore. We'll go ahead and power down. Just simply unplugging it. Boom. Put this guy away. Now we can start our post-processing and clean this up and turn it into a usable 3D model. Here we are in Revo Metro, the software we use to do our 3D scanning and post-processing with the Revopoint 3D scanners. We've got 4 scans. They all look pretty good. Yeah, no complaints. Ooh, actually, here's a complaint. Look at that. We got some bad feature matching here. We've got enough scans. I think we're gonna get rid of this one. Double check again. I think everything else is good. I think we have any feature matching issues anywhere else. Is that some there? I don't know. It might just be the curvature of the cubby. No, I think they're good enough. There's a tool with the Revo Metro software. It's kind of one-click edit. It'll conduct your fusion. It'll mesh it and texture it if you used RGB camera. We didn't use the camera for this one, the RGB camera for this. So we can't texture it, but we will fuse and mesh it. I don't really like using the one-click tool. I like to take it a little bit slower and do it myself because you'll generally get better results. So we'll let this run. I haven't used this software too much, but I've used lots of other commercial 3D scanners. But I think once it's fused, we'll get access to these tools and we can go ahead and delete all of the outliers, the big outliers that a general outlier delete tool wouldn't pick up. All right, for a quick fusion, not too bad. So yeah, we'll take the lasso tool. We'll just start grabbing and deleting. We got one more. Boom. All right, so hop to the second one. We'll do a fusion, trusty lasso tool. Not too bad. So we got three reflective markers that we picked up here. Oops. So there's that. 1, 2, 3. Got a lot here. Go ahead and shoot. We'll cancel that. We don't want one click edit. Alright, we got more. I just touched my trackpad. I think my mouse battery's dying. Not responding the way it should, but we'll get this done. Alright, overlap detection. Let's see, do we detect any? I don't think we will. Yeah, we're not worried about that. Smooth, you know, I don't really think we need to, let's just see what happens. Yep, pretty much nothing. Simplify, don't really need to simplify. It's pretty small scanner. Let's try do a high quality mesh. I don't think it'll take 4 minutes. Yeah, there we go. Some of the most important features for this part are these 2 tabs here and the 2 tabs at the bottom that we actually didn't get. So hopefully the other scans will have those. And then these guys, they are pretty important. And then really this face curvature right here, because we're going to make a surface model based off of that to fill it in. So we got one. Next, mesh, apply. All right, not too bad. Right, 1, 2, we need 4. We got a mesh, right? Yes. All right, mesh this guy. Then I think after this, no, not too worried about filling any holes or any additional smoothing. We'll go ahead and try doing some merging. So 1, 2. So we got the 2 pieces. We just need to match a few points and click generate model, and it should attempt to merge them. We're not going to get too much out of this. Actually, this should be decent because we got a backside scan and then a front side. Get them in the same general orientation. Let's see, we'll go for a back top corner. Same here, 1, 1. We'll do 2, 2, 3. Oh, 3, 3. So it's already getting pretty close to 4 and 4. How's this? It's not too bad. There we go. Now we got 1, 2. We got all 4 tabs that we're really concerned about. And then that next model should get us everything we need. So click generate model. Boom. Now we've got a merged one plus the other piece we didn't merge previously, which this is I think the best scan. All right, do the same thing. 1, 1, 2, 2. Oh, 2. That wasn't very accurate. We'll see what happens though. 3 and 3. I don't know if we need to do more, but let's just see if it makes it any better. 5. Yeah, I don't think it really changed much there. All right, generate model. Now we've got a second merged. I think that's it's pretty decent. Yep, we've got our tabs here. 1, 2. Then we've got 3 and 4. So these bottom 2, you see they've got this extra lip here. That's to keep it from popping, from falling out of the vehicle. And these top 2 are just for locating. And then these side pieces are really just for alignment. We're going to export. All right, we got to go back a few steps. I messed up. So now we need to mesh this. I knew something was a little funky here. Yeah, now that looks better. Now you can really see the tabs. 1, 2, 3, 4. I think we can, I think we'll be able to make this work. We'll go ahead and export this mesh model. Do model origin. Makes it a little bit easier. Save the OBJ. Actually, no, we don't want to save it there. best place to save everything, your desktop. So here we are in Fusion with the completed 3D model with the scan data. Starting with here, this is a 3D scan I did of the truck interior without the cubby. Just did this for a good reference so that I can match this back up with my design. Got these tiny holes up here for locating features, 2 down here, tabs here. There are also some tabs on the left and right. Turned out pretty nice. It's also pretty cool. You can see this small spot right here where it's slightly raised. So that's where I put one of the reflective markers for the scanner. And then I cut out all of the excess area that got scanned that's not really needed. There's the ESP32 screen I'm using. For some reason, the actual screen I have, the LCD part goes from end to end, like to here, but this one doesn't really represent that. But it actually, I mean, it's the same exact piece. The same mounting features. Here it is all put together. Got the 2 switch blanks we'll put back here just in case I ever want to use these switches. I can go back and do that. You'll see it's not a perfect fit. There's this slight, it's got this slight curve that goes back through here. I added a little bit of it in the model, but not enough. And then I got too far into the design of it to easily go back and fix it. And you can't really notice it in the vehicle when you're sitting and looking at it. Fits decently, you know, it's not perfect, but like I said, when it's in the truck, it looks pretty good. I'm happy with it. I'm not going to go down into how I designed it and all of that stuff. There's plenty of videos on YouTube for you to learn Fusion 360. It's pretty intuitive. You can pick it up pretty quick. Just finished. Pull the supports off and get to work. Some people really enjoy removing support material. I can't stand it. And I think it's because at one of my old jobs, we used to do production 3D printed parts. I spent so much time removing support material from 3D printed parts. Fortunately, this tree support comes off decently easy. There we go. Turned out pretty clean. This right here, this is a deburring tool. It's one of my favorites for cleaning up 3D prints. Just go through. Gets these little sharp burrs off. Then I'll go back with sandpaper later on. Microplastics everywhere, dude. Quick comparison of the two. Got the OEM piece from the Tundra. Got these 2 switch blanks. These pop in. Oh yeah. Nice and satisfying click. The fillets match pretty good. Can't complain. Oh yeah.
Hey, that's pretty good.
Looks OE, right? Next step is spending a lot of time with some sandpaper to get rid of all the layer lines, then a bunch of paint, then install, and heat set inserts. Actually, we've got this. It's a 2.8 LCD screen, IPS display, so it should work out pretty well in a vehicle with sunlight. You can see it from a steep angle. Yeah, it should work out pretty decently. It's got an ESP32 chip built into it, pretty easy to work with. There's a lot of features on this that I'm not going to use, like it has a microphone, but it was $17 and should work out pretty well. Yep, there we go. Look at that. It's not too bad. Time to clean it up and get ready for some paint. Here it is, fresh off the printer and all the supports removed. Did like 5 walls thick, so it's quite dense because I kept breaking off the tabs when installing it. Hopefully this makes it a little bit stronger. We'll see. Don't really know. Now we got to prep it for paint. So I've got some 180 grit, 220 grit. Gonna introduce some more microplastics into the world. It's gonna take a while. A few minutes of the sandpaper and looks a little bit better. I'm also using a high fill primer, which I think will fill in any of the gaps. It's not perfect, but give it a shot and see how it looks. Now we've got our high quality paint booth out here and this 5-year-old primer. Let this dry for a bit.
2 hours later.
Here we go. We've got the absolute cheapest flat black paint you can get from Lowe's. All right, add a little bit more in a bit.
5 minutes later.
Looks like the paint's mostly dried. Most of the layer lines are, some are visible, but it's not too bad. I'll give it a light sanding and one more coat and call it good. Got it cleaned up, got the switch blinks installed, do a quick dry fit, see how it looks. See, truck's a little dirty, but back here it's not too bad. Let me know what you think. Okay, let's head back inside and get the screen installed and wrap this thing up. So now we're going to add in these 2.5mm heat inserts. It's a pretty simple process. You heat up your soldering iron, then we'll take one of these and very quickly, you always want to try to get it as perpendicular as possible. There's 1, 2, 3, 4. Next up, put the screen in. Got our display, drop it in. There we go. Now we have a bunch of the M2.5 bolts. We are going to use these extremely short bolts, which are 4mm long with 1 washer. Now, I don't remember where I got this from or why I have it, but I have it and it has the connector that you need to power this board up. So verify we didn't destroy the screen when tightening the bolts. There we go. Let's go install it into the truck. So here we are in the truck. We've got old bracket removed and install this new one. So the truck's not wired up for this yet because I need a 12 volt to 5 volt converter and just haven't gotten around to it. But we're going to use this small battery again just to show you how it works and how it looks installed. There we go. Connecting. So pop it in. Nice and easy. I think it's already connected. It said fetching. Yep. Now it should be loading everything. Now we're reading the live data that's being transmitted from the OBD2 scanner. You can see we've got the RPM, coolant temp, speed 0. We're not moving. There's a few PIDs that I'm not properly reading or not reading correct data from. But right now you can see what we have here. We've got a few different tabs of some different data that's available over the OBD2 port. Went through battery voltage, cat temperature, timing advancement. I've also got the brightness here. So once I have it wired into the truck, I'm also going to wire in the headlight switch. So headlights off, brightness would be very high, so you could see this in the day with lots of sunlight. And then whenever it's dark, turn the headlights on, and then we'll drop this brightness down to 5 to 10%. Gotta calibrate and see what looks good, just so you're not blinding yourself when driving around. Now the cool thing is you can read all of the diagnostic codes and also clear them. Fortunately, this old truck doesn't have any active diagnostic codes, so there's nothing there. You can clear, confirm, DTC's cleared. So overall, it's got some decent data. Realistically, I don't think that I'll be looking down at this very often while driving. The coolest thing is the fact that you can read and clear the diagnostic codes, and it's utilizing this space that was previously never used.